This tutorial is discussing acid-base equilibrium. So when we talk about equilibrium, we're talking about two reactions that are taking place at the exact same time. We have the forward reaction and we have the reverse reaction. So you'll notice that in the forward reaction, the F minus is on the right-hand side. It's a product. However, in the reverse reaction, the F minus is on the left-hand side because it's a product. What's going on is these reactions are happening at the exact same time. So HF is being broken apart, and then it's reforming and taking the hydrogen away from the H3O. So those reactions are occurring at the same time, a forward and reverse. They use those terms quite often, forward and reverse. Once equilibrium has changed, the reactions are at the same speed. It doesn't mean the reactions stop. The reactions continue to keep going back and forth, back and forth. However, they're doing it at the exact same time. At the very beginning, you're going to have a lot of reactants and very little products. Then, as the reactions proceed, you're going to get to the point where there change in actual concentrations. It's the concentrations we're looking at are going to remain the same. So once again, the reaction is not stopping. It's just going front and back at the same speed, at the same rate. They refer to that as the rate of the reaction. So before equilibrium is reached, the concentrations of the reactants and the products are changing. We're not looking at equal concentrations. They may or may not be equal. In fact, they will rarely be equal at equilibrium. It's the rate in which the reaction is happening that will be equal. Initially, reactants have a rate of the reaction which is faster than the rate of the reactant of the products. So the reactants are reacting more quickly than those of switching back. At equilibrium, the rate of the forward reaction is equal, and that's where that term equilibrium, to the rate of the reverse reaction. We're talking about the rate of the reaction, not the concentration, the rate. Chances are you're going to have more products than reactants at the end. It's the speed at which it happens that we're looking at equilibrium. At equilibrium, the concentrations of the reactants and the products are not equal. So we're looking at concentrations here. They are not going to be equal. It's the rate that is equal. This brings us to Le Chatelier's principle. Le Chatelier is basically saying that if the reaction is somehow disturbed, if you added something, if you took something away, if you heated something up, it would change how the reaction is occurring. So here is something at equilibrium. If we add, let's say, more water to the left-hand side, eventually enough water is going to come over and fill that space up, so that way we still have equilibrium when we're done. Notice that the rates, the levels are the same here. Once we add stuff to the left, the rate will end up being equal again at some point. And that's what Le Chatelier was saying. So here's an example. HF plus H2O yields F minus plus H3O plus. If we're adding more HF, so we're adding more of this, what's going to happen is it's going to try to even that out. We want to hit a point of equilibrium. If that HF is there, it's not at equilibrium because you have more stuff there and it's unbalanced. So it's going to, we say, drive the equation to the right, or the forward equation. By adding stuff here, it's going to push it to the right side, push it to the forward reaction. If we do the exact reverse, if we remove some of that HF, it's actually going to drive it to the left or produce more reactants to even it out. Think of it as a scale tipping from the left to the right. If you add more to the left, it's going to tip it to the right. If you add more to the right, it's going to tip it to the left. Okay, so more F minus we're adding here, it's going to drive it to the left, so it's going to make the reverse reaction more dominant until it hits equilibrium. So here's just a summary of the breakdown. If we add reactants, you're going to drive it to the right, increase the forward reaction. We're going to get more products. If we remove the reactants, it's going to do the reverse. It actually produces more reactants. You're going to drive the reaction to the left, producing more reactants and increasing the reverse reaction. If we're adding products, that means, let's put if we're adding more products, we're going to drive it to the left, increasing the reverse reaction. If we remove some of the product, take some of that out, it's going to drive it to the right, producing more products. So let's just do a little summary of just making sure we're all on the same page. So here's the reaction. H2CO3 plus H2O yields H3O plus and HCO3 minus. If we add H2CO3, we're adding some of this. That's going to drive the reaction to the right. You're going to end up producing more products in this procedure. Okay, so here's the same equation. What if we remove some of this? We're taking that out of the reaction. You're going to end up producing more products again to try to fill that void. You're adding H3O plus here. So we're adding that. So since we have an excess of H3O, it's going to get pushed to the left. You're going to end up producing more reactants. And that's how you do equilibrium in Chatellier's principle.